f-test for testing multiple restrictions in our regression and can be expressed in many ways. This is one expression. We're comparing the R-square from a restricted model with the R-square from an unrestricted model. The unrestricted model, R-square, is larger than the R-square from the restricted model. And because R-square can only increase when you add more variables. All right. Now, the number of restrictions is this number Q. All right. So we want to compare the increase in R-square to the proportion of unexplained sum square error, because the R-square in a model is the percentage of the error that's been explained in the model. So 1 minus that is the percent that's not been explained. All right. So the each one degree freedom, here we have n observations. We have k regressors in the model under the unrestricted model. And also we have an intercept term. So we lost k plus 1 degree of freedom. There's more than one formula for the f-test. All right, so there's another formula. The f-test is expressed in terms of residual sum square under the restricted model, subtracting from the residual sum square under the unrestricted model. We know the residual sum square is nothing but the observed value deviates from the regression line. That distance squared, we add them all together. So we divide the reduction, the sum square residual for the unrestricted model is smaller than the sum square residual from the unrestricted model. So this difference is always positive. All right, so we want to see the reduction in the sum square residual divided by number of degree of freedom in that difference in two models. Now that number is divided by the residual sum square under the unrestricted model, and again has the same degree of freedom that we said in earlier slides. Now, if we think about this, remember the sum square deviation from the mean. If we divide by the standard deviation of that variable, and that become a chi-square. Remember, chi-square is normal random variable squared, right? So you can think of this, each one is divided by the standard deviation. So what we have is a ratio between the chi-square on top and the chi-square on bottom, which give us the F distribution. All right, so let's see how this formula is different or the same as what we had before. Now, R square is nothing but 1 minus residual sum square divided by total sum square. All right, so in that sense, we can rearrange. See, we can put the residual sum square divided by total sum square, move to the left, move the R square to the right, and then we multiply both sides by total sum square. We come up with this equation that residual sum square is nothing but the total sum square times 1 minus R square. All right, so now let's replace the residual sum square on top with the total sum square times 1 minus R square. So now we have the restricted over here, okay? Then we have unrestricted over here, and each one times total sum squares, we move them outside. Now we do the same thing for denominator and upper, the earlier equation. All right, so now total sum square cancel out. So that's why these two formula are the same. I hope that helps you to understand the formula.